We're going to take a look at the Mach3 SDK and how to operate the Mach3 SDK. You can see Mach3 SDK.exe has been copied into my C Mach3 plugins folder. And in this folder, normally the only thing for a user that would reside is these DLLs. You can see I have a joystick DLL and I have a blank device DLL. The blank device DLL is not normally distributed with the application. It's just there for the Mach3 SDK users. Basically, whenever you wish to create a device, you will copy the Mach3 device to another folder and expand it to create a device and then rename it so that you have, for example, Mach4 joystick, which is what I called the development package for the joystick DLL, which is included with the release. Let's take a look at what happens with Mach device. This folder is created when you unpack your Mach3 SDK. You can see it is a typical Visual Studio 2003 solution. It has a normal release and debug folder, which are only used for the intermediate files. We have a Mach includes folder, which includes many of the H files from Mach3 to give you access to many of its variables. Let's open up the solution. And here we have our main file. The main file of our skeleton is Mach device. And there's a couple of things that you need to do prior to using it for your own work. If we do a properties on Mach device, we can see that under linker, we're set to output a file called blankdevice.dll. You should change this to reflect the name of the device that you're developing. That's really the only thing you need to change in terms of what your output device will be called. You'll notice that I've changed it to /blankdevice so that the DLL will be placed into the plugins folder. It goes back one folder, in other words, and places itself in plugins. Also, for debugging purposes, under the debugging tab, you'll see under command I have set it to C Mach3 Mach3.exe with a working directory of C Mach3. This allows me to run the add-in or plug-in that I'm doing and do proper debugging. I'm going to switch this to debug so I can show you an example. There's one other thing in the resource menu under version. The only resource that's included with the skeleton is a string file, and you'll see here that company name is Artsoft. You may change that to whatever you wish, and file description is blank plugin. If you take a look at the joystick plugin, you'll find that it is called joystick plugin. So those two areas that you change will give you full access to making your DLL look like your own and feel like your own. Let's take a look at a few of the things in the Mach device. It is the only file that you really need worry about other than your own code. You can add classes to this file, you can add dialogues, you can add it as you wish, and you'll see examples of that in the joystick DLL that we'll take a quick look at. Under System Variables, you'll see we have a pointer to a CXML profile object called devprof. Devprof is used to get access to the XML file in Mach3. It is a restricted pointer. You can only use it during two areas of this DLL while it is running. One is during the configuration, and the other is when the profile name is actually set. We'll go over that in a moment. You can also see that I've instantiated about 6 routines, do button, and you can see in the comments I've given you an example of how to use it. You can use these at any time in your DLL, and those familiar with Mach3 script will recognize them. It's do button code, double get DRO code, void set DRO, get LED. C-string get pro name is not something that you will need to use. This is used in conjunction with the CXML profile. And then there is code for sending G-code straight to the program. We have instantiated as well 4 pointers that are automatically filled at the time that the DLL is started up. These 4 pointers represent 4 of the major classes of Mach3. There is the main planner, used to run most of the code in Mach3. Mach-View is used to control the windows and frameworks. Engine is the ring 0 variable block for the printer port and some other operations. Changing variables in Engine can trigger movement, can get direct access to the ring 0 ports and pins and various things inside your kernel. And then there is setup, _setup, which is a pointer to the trajectory planner, RS-274 information, and various configuration data of your trajectory planner. Most of the primary code here you shouldn't touch. You can add message maps if you wish for your plugin. The application configuration you may add code to if you wish to do specialized configuration or create classes that you may have created to do various jobs. I would ignore most of the rest of it. It is C++ specific. Mach3 is taking some liberties with these plugins, so you're going to get some crashes and some faults if you start to play too much in the class object registrations and so on. So most of this you can skip right down and ignore the external specifications that I've made for all of these codes. Again, those are important to the initialization of the plugins. You can do that right down to set pro name. Set pro name is called by Mach3 to set the profile name and instruct the plugin where to store things and get things from an XML profile. You'll see that I've created a devprof is equal to new CXML profile, and right afterwards I've deleted it. In between those two calls, you are free to read or write to the Mach3 XML, so you can get any data that a user is storing in his Mach3 XML profile. Then we return a name. This name is important. It shows up in Mach3 under the plugin configurations so that you can tell which plugin is which. It's noteworthy that you can run several copies of one plugin and they'll all come out with the same name. There will be no way to differentiate between them, but you could use that as a multi-thread sharing routine to increase the amount of work being done by a DLL. We'll learn how to use that as time goes on. You can see that what I'm doing in this set pro name is simply returning one thing, and that is the name of this particular plugin, and in this case it's a blank. Now we have calls into the DLL. These are calls that Mach3 makes into our skeleton DLL or into any plugin. The first thing it does is call init control, and again you are advised not to play too much with this init control, with the primary purpose of it is to set the engine setup planner and Mach4 view variables. Then you'll see a notation by me saying the following area is for your control initialization. You're free to add any initializations that you wish for your plugin in this area. We then have a config. In Mach3, you can press a config button for any profile, for any plugin, and this is where a dialog would open to configure your plugin, or you can set up any configuration data. You'll see that this particular blank does nothing other than create an XML profile, so you could read or write to your XML, and then deletes it afterwards. I'm not using it in this skeleton. I just send a message box saying no configuration for this blank device. Then we have the most important routine, which is update loop. It's called approximately 10 Hertz or so, and in it you can do things at a loop frequency of Mach3. In other words, every time Mach3 loops through its internal routines once, it will call this update routine, and you're free to update your plugin or check the states of Mach3 to set internal variables to the plugin so that you can see exactly what Mach3 is doing at any given time. Since this is a skeleton, there really isn't too much set in here. However, since I have the system set to send a debug to this program, or to run this program in debug mode, we can, for example, set a breakpoint here in the init control. So we're going to stop here when Mach3 initializes to the point that it tries to initialize this particular plugin. I just hit compile and we're linking. We've succeeded. So we're going to hit F5 at the moment to start the plugin. And what will happen is Mach3 will normally start up its normal way. I'm going to select the Mach3 mil profile for this instance. And as you can see, we've just stopped in our plugin at init control. Mach3 is not running in the background at the moment. It is halted. It is not a multi-threaded connection to a plugin. This is in order to conform to certain internal intricacies of Mach3 and to maintain a synchronicity with the XML profile file. But all we've done in this particular initialization is set pointers to our engine, setup, Mach view, and Mach planner and main planner variables. If we look down here at our watch function, let's slide this up so you can see a bit more. And I realize the video here may be very bad, so you're going to want to try this yourself. You'll see that what I have is 4 variables set into my watch: engine, setup, main planner, and Mach view. By opening up engine, for example, you'll see that we have a couple hundred variables that which you can get access to. You can get them and change them by using the pointers provided. You can see that there are structures. There is, for example, trajectories. Trajectories is a list of all the commanded moves which have not yet been sent out. Traj index and traj head are ring buffer variables pointing into trajectories. When there is movement going on, these variables will point into movement information in the trajectories queue. We have a lot of variables here, and there's no way I'm going to be able to explain all of them to you, so this will primarily be done on a request basis of letting you know where you can find a particular variable to do a particular thing. Some of them are obvious, such as emergency. If it is true, then an emergency stop is in effect. Jogging, if it is true, the user is currently jogging. Incremental jog means you are in incremental jog mode, etc., etc. There are a lot of these. Port 1 and 2 on, you can see both set to false at the moment. This init control is set before Mach3 has fully started up. So port 1 and 2 are both off because Mach3 does not know yet that they're turned on. It has not done its primary initializations. So really this init control routine is not a good place for you to change variables within Mach3. You should wait until the configuration or in your update loop to change any of these variables. At that point, these variables would then be instantiated. For example, if we were to go down to our update loop and put a break there, we can see right now our port 1 and port 2 are turned off in the engine. So we're going to start up Mach3 and let it go the rest of the way with an F5. And it will take Mach3 a moment to catch up with us. You can see threads are loading. And here we have Mach3 running properly. We can reset it, for example, and I can jog around. The program is running. If we go down to Configure Plugins in the Operator menu, you can see that our blank plugin is not yet enabled. This is because it's a new plugin, and all new plugins are disabled by default until such time as you turn them on. The system will remember that it is an enabled plugin, and from then on it will be automatically enabled. And that's why we're not stopping in our update loop in our plugin. If I hit Enable, you can see we instantly stop into our update loop, and we'll continue to stop here 10 times a second. Let's take a look at our engine. You can see now that port 1 on is set to true. This is because all of Mach3's variables are now fully instantiated and set to reflect the true status of Mach3 at the moment. So we can see our port 1 is on. We can see our port 1 address, our port 2 address, where it is set to. We have axis structures, and you can see that we have 7 axes. The 7th axis is actually our spindle. Axis 0, I'll open up so you can get an idea of what goes on for each axis. We have an index variable. This is the master index of Mach3. This is something that I've said before, I never touch except when you're homing. The index and master index tend to reflect each other, and they only differ in special circumstances that I won't go into unless I have to. We can see where our step pin is for a particular axis, our dir pin, which port our step and dir are on. Are they low active or not? Current velocity of an axis is always stored as the program runs. Maximum velocity is a clip variable, which stops us from jogging too fast if we're jogging. We have a master velocity, master velocity is a clip variable. Max velocity tells the system if I was to start to jog right at the moment, this is the maximum speed it is allowed to accelerate to using this acceleration variable. At speed tells us if this axis is now up to full speed, so it's finished its acceleration phases. We have accelerate and decelerate variables, which tell us whether or not our axis is accelerating or decelerating, and these are actually trip variables, which can tell an axis to start decelerating or accelerating up to a master velocity limit. You don't even try to follow these explanations, by the way. I'm simply giving you examples of what they do. You're going to have to play with a lot of them to see. Enable tells us if an axis is turned on or off. You could disable an axis, for example, just by setting engine axis, whichever axis, .enable to false. We have a jogging variable telling us whether the axis is jogging at the moment and a jog direction that it is jogging. We have a homing variable telling us if an axis is homing. Or a deref variable telling us if an axis is currently moving to get off of a switch. We have 5 memory variables which can be used for each axis. Currently they are unused. We have an active memory telling us which memory variable we're currently interested in. Again, it's currently unused. We have a color variable, which is used for setting a DRO color for a particular axis, so an axis could flash at a particular color during particular instances. Trip count, depth count, probing, slave, and slave axes are all internal variables to those axis structures. Again, when you need a particular variable, let me know, and I'll let you know what a particular variable does, and we'll try to create a rudimentary documentation of all this as we go. You can see we have a variable in the engine called insigs. Insigs is a list of all the input pins. You can see that there are hex 34 of them, and each input, for example, input 1, we can tell whether it's false, what pin it is, what port it is, whether it's negated, its required state, it's activated, it's emulated, and what its emulation key is. So there's a structure for each input signal, and there's a corresponding structure for each output signal. We have structures for the encoders that you can read where they are, what state they're in, what their last state was, what their count is, and which direction they're going. We have limit positions, we have a great many variables, and there's way too many for us to go into at the moment. You're going to want to look through and see if a variable name makes sense. I tend to name variables so that they make sense to me and they make sense to others if they know what's going on. Some of them, of course, can be hard to figure out without my assistance. You can see, for example, a variable max NC mode set to false. If we were in max NC mode, that would be set to true. These variables are read by the kernel's ring 0 25,000 times a second in 25K mode. So changing one of these variables can make an instantaneous change in movement to the system. Be cautious with the engine block. The engine block is extremely powerful. It has the capability of changing any port in the CPU, and it has complete control of your motherboard. So a word of caution when playing with engine. You're not likely to hurt anything device-wise, but you are likely to blue screen of death if you do too much playing around in there with variables that you think you understand. Then we have the setup block. Setup block, if I open it up, you can see that it really reflects all the states of the trajectory planner. I realize this is hard to read, and again, you're going to want to do this yourself, but you could see, for example, here's our current work offset, or AA axis offset for the A axis. My apologies, that's the G92 offset. We have many offsets. We have active G modes, which will list 15 or 16 of the current G modes that are in effect, G1, G2, etc. Active M codes will tell us if there are any particular M codes currently in effect. We have G92 settings for X, Y, and Z. Changing any of these numbers will change those offsets. However, there are synchronicity issues with the Mach3 engine, and you're always better off to change such things with a code call, such as G92X0 through the code facility, which will synchronize between the trajectory planner and Mach3. We have control modes. You can see that there are, after, for example, someone is called for a can cycle, these will be the variables for that can cycle. Distance mode, you can see, is set to mode absolute. Because I've included the H files, often when you're surfing through these variables, you will see constants like mode absolute. I did this as a way to try to pass to you as much information as I possibly can about how the system works. And an experienced C programmer playing with the system, I believe, will actually find it quite easy to use. As you're going through it, it also tells you what kind of a variable it is in this column. You'll see that, for example, origin offset X is currently 4.126. This is the work offset for the X-axis at the moment. Those of you who have been wondering about how many decimal places, you can see that there's a great many decimal places for all offsets in the program, and it tells you it is a double. You'll see character pointers, you'll see integers, etc., and it tells you basically what they are so that you can get an idea how to use them. For example, if you wanted to reach into a tool table, the tool table is included here as well, and there's our index into the tool table. Currently we're on tool number 0. We can have a tool max of FF or 255 tools. All of this could be changed by a plugin, so again, be careful. I won't go through all these variables, of course. There's way too many of them to go through, but again, you're going to want to play and figure out which variables you need for a particular application. Then we have our main planner. Main planner is the main control loop. And as you can see, some of the variables like home and slave, this tells me the slave number of Peter Homan's mod IO board. M_reverse arc. This would cause arcs to reverse their direction from a G2 to a G3. Again, you're going to want to look through, do hotkeys persist? They're set to false at the moment. Laser stops, laser baud rate if you were speaking serial to a laser. There are several hundred variables here, all of which are attachable. You may want to set up Mach3 so it's set in a particular state, set a variable to a magic number that you could search for here and say, there's my variable, this is the number it is set to, and then you're free to play some games with it. For example, probe XYZ ABC would be the actual position when a probe switch got hit. You can use these plugins as a master macro pump. For a C programmer, this is a much more powerful way of doing a macro pump and allows him to control to an unprecedented level what you can do in a macro pump. Then we have Mach4 view. By the way, don't get confused about Mach 3 versus Mach 4. Internally, Mach 3 has always been called Mach 4 for a very long time, since the OCX was dropped a long time ago. So you can think of Mach 3 and Mach 4 as interchangeable words when I'm speaking about these things. I tend to use both. Now you can see that we have a pointer to a view. So you could actually attach to that view and change the way the windows look. We'll be doing some experiments with that with flash controls and so on sometime in the near future. We have many variables such as the number of hot controls, the number of controls in the program, the current tab that you are on in the program, which would tell you which window is currently being displayed. We could say how many tabs and where the tabs reside. You can look at what is the loaded screen. Some of these variables you will be able to get access to, others you will not be able to get access to. It's very difficult to pass structures across DLL boundaries and plug-in boundaries, but I've tested a great many of these and they all seem to work fine. Then we have such things as OEM DROs. Here are the values that are currently stored in all of the OEM DROs, all 255 of them. So as you can see, there are probably something in the order of 1,000 variables in each of these 4 classes that you can play with. If I turn off my breakpoint and I continue, you can see that I've enabled the blank plugin and the joystick plugin currently. So let's take a look at what happens when you press config. I'm going to put a breakpoint in my config on the DLL, and I'm going to press the config button. Instantly we stop in our config. First thing I do is create an XML profile, which we're not using in this DLL, and I delete it afterwards. And the only configuration in this particular blank skeleton is a message box which says there is no configuration of this blank device. I'll hit F5 to continue, and as you can see, we have a message box which says no configuration of this blank device. So we can hit exit. Mach3 will work normally. One thing about this Mach3 is I'm going to bend my joystick around a little bit here, and you can see that I'm now jogging by joystick on the X and Y axis. If we take a look at our configure plugins, you'll have noticed there is a joystick plugin. If I hit config for it, I open up a dialog which asks me which axis do I wish to jog. If I was to change this to the XZ axis, because I have a lathe, the jogging joystick will now jog my X and Z axis. That's an example of the joystick DLL working, and let's take a look at that joystick DLL so you can get an idea of what I mean by the way this is all configured. I'm going to exit out of this project that we were in. I'll back up one to our plugins folder, and you can see I have a Mach3 joystick DLL. You'll notice they're all called Mach device. They're all built off of the same skeleton. I've just added a few classes to this one. So let's take a look at a working plugin that actually does a job for us. As before, you'll notice that it looks almost identical. The exception being I've added some comments, added for joystick control, and I've added the multimedia system and a joystick.h, joysetup.h to the system. Joysetup is my dialog for controlling the joystick. The rest of this tends to be normal. I've added a block and commented it as joystick variables, and you can see there aren't many variables to control a joystick. It goes to show just how easy it is to control a joystick. I've also only had to add 3 routines, which is check the joystick, jog by stick, and set up joystick. The rest of this DLL is identical until we get down to the configuration joystick plugin. At set pro name, which you'll remember in the blank DLL was pretty much blank, I've only added 2 things. A call to set up joystick, and I've changed the return to joystick plugin Artfinity May 2006. This is what shows up in Mach3 when you pull up your plugin dialog. Let's take a look at setup joystick. The reason I'm calling setup joystick in between the call to devprof creation and devprof deletion is because I wish to use Mach3's XML variables to set up my joystick, to see what a person may have set for acceleration and so on. So let's go down to setup joystick. Here's our routine for setup joystick. First thing I want to do is fill variables to tell me which axis I'm currently using for each movement of the joystick. I do that very simply with a devprof getProfile integer jog plugin jog plug horizontal with a default value of 0. If you look in your XML file, you will find these key words. Under the heading of jog plugins, you'll find a variable called jog plug horizontal. If the XML contains those 2 keys, this call will return that variable into xjoyaxis. If these words are not in the XML, the default of 0 will be returned to xjogaxis. This allows me to set a default in my plugin and to pull actual values back had they been stored in the XML. Same thing with enabled. with enabled, I am asking Mach3's XML file, has this person enabled this joystick plugin? If he hasn't, don't jog with it. If he has, remember it. And I remember it by writing those variables into the XML at some point during the run. During the setup of the joystick, I don't write anything, of course. I'm only interested in reading variables from the XML. Now you can see here, for example, I'm creating some C strings and getting variables by C string format. For example, the velocity of an axis is stored as vel0, vel1, vel2. So here I am creating a vel1 because xjoy axis is currently set to the x-axis. Therefore, I want the velocity of the x-axis, so I can set up velocity and acceleration variables. When you play with this, you'll find out how it's done. You'll notice I divide by one of my engine variables, PPS, which is pulses per second. In order to calculate a proper acceleration, I have to know what speed the engine is going, other than just number of steps per time. So I divide by engine pulse per second, and there's a magic number, 2048, that I multiply by simply to give myself a double-digit precision of an integer in the engine when I'm actually doing accelerations. Again, I realize that's gobbledygook to most of you at the moment, but you'll figure it out as you go and begin to play with accelerations and so on. So setting up the joystick only takes about 15 lines, and all I'm doing is remembering accelerations and velocities. If you were to call config, you'll remember our skeleton was empty. All we did was create an XML profile and delete it. Well, what I'm doing now is calling a dialog. If you create a dialog, you may call it here. After the dialog has been called, I then reach in and grab information from it, and I store it into the XML profile of Mach3 under jog plugin heading. I then delete the profile. You must create the profile and delete the profile only in the config or set proname functions. Otherwise, Mach3 will not have access to its own XML file, and it won't be able to change its configuration from that point forward. So basically, the configuration simply allows the plugin to turn on and to save variables as to which axis you wish to use. This is a simple plugin. It could be expanded a vast amount to use all of the controls on a joystick and to do various things with various controls. And it would be very robust and quick at that point. Then we have our magic update routine, which is called up to 10 times a second. And all I'm doing in this routine is this first section is almost always unused, but when the system first turns on, it checks to see if it is the first time it's turning on, checks the joystick to see if the joystick is zeroed. If the joystick is leaning to one side as this plugin starts up, you'll get a message box saying, I'm disabling the joystick, it fails a configuration test, check its connections, calibrate it, and restart the program. This is because I don't want any axis takeoffs if the joystick is not sitting at center when the system starts up. If it is sitting at center, from then on, you'll see by the logic, these lines are then ignored, and from then on, if the joystick is turned on and the engine has told the joystick to turn on, jog by stick. The jog by stick routine is also pretty small. Here we are. It's just about 20 or 30 lines, I think. And it jogs. And it figures out basically a percentage the stick is moved and then calls a little routine here which causes jogging. You can see here with 4 simple lines we're causing the system to jog. In the engine block, we pick an axis with axis joy axis. We set a jog direction by simply setting that variable to the proper direction. We set a maximum velocity, which is the currently scaled value of the movement of the joystick. We set an acceleration from the acceleration parameters that we used earlier. And then, in order to start the jogging, all we need to do is say jogging is equal to true, which we do down here in another routine. When jogging gets set to true, Mach3 will instantly start to jog the axis using the proper acceleration up to the maximum velocity, which has been set up here under max velocity. Master velocity is the limit of speed. So jogging is all automatically performed by the Ring 0 driver in Mach 3, and it's just a matter of learning how to set the variables to create a jog movement on an axis. Again, those of you with interest in that area, you can ask me any questions you might have, and I recommend that you play a lot with this area, because when it comes to controlling Mach 3's internals, playing with them is the only way that you're ever going to be able to figure out exactly what I'm doing. Well, that is a light introduction to the SDK. You'll see that because, one other thing I'll mention is because we're in a joystick SDK, you'll see that I have renamed a couple things to say, under linker, I'm now calling it C Mach 3 plugins joystick.dll instead of Mach device. And under our resources, we now have more than one resource. We have a dialog as well as a version, and inside our version you'll see I have renamed it to joystick plugin. Those are the only two changes I did from the skeleton device when I designed this joystick plugin, and you should do the same thing when you create a plugin. Change its name, change its version, and from then on, you're well on your way to creating your first plugins or modifying my joystick plugin to control your 53-axis whiz-bang joystick with force feedback control. All of that can be done with the plugin. It's fairly simple to do it, but obviously my view of what's simple is going to be a little bit different from yours because I'm quite familiar with it. Ask questions, yell at me when you have a specific question on a variable or where to find a variable. Most of the variables are stored in the places that I've given you access to. If you wish to get DRO values and so on, use these calls: do button, get DRO, set DRO, get LED, and get and code to send code directly to be executed by Mach 3. All of those functions will work within the context of Mach 3, and it's pretty much invisible to the system. That's it for now. I just wanted to give a light explanation of the SDK, because I know from experience how difficult it is to load other people's code and start an SDK project. Remember to unpack your SDK into the plugins folder. It makes it a lot easier for you to do debugging and to grab and hook your plugin as Mach 3 runs. Don't hurt yourself and expect frustration when you're dealing with this kind of thing. The joystick plugin only took me 3 hours to write, so it really seems to be functioning quite well. I haven't done anything that really explores all the power of Mach 3 yet, but I will be publishing further plugins as I develop them so that you can get an example. That's it. Good luck. Have fun.